introduction to the nature of energy. So energy is actually the ability to do work, and work is applying a force through a distance. So you have to be able to move an object in order for work to be done on it. This causes a change in motion or in temperature, or this causes some type of change within the object. Both work and energy are measured in what we call a joule. Work is an unbalanced force that makes an object move. So really it's a transfer of energy from you to the object, or from one object to another. If there's no movement, then there's no work. So the wind is going to transfer the energy of motion from the wind into the sails to make the boat move. Or if you put your car in neutral and you start to push it, you're applying a force to the car, and so the energy from you goes into the car to make it move. So mechanical energy is the energy that has to do with an object's motion, position, or shape. So mechanical energy is actually the total, or the sum, of an object's kinetic energy plus its potential energy. So we shorten this by saying that mechanical energy, ME, equals KE plus PE. Kinetic energy is associated with motion. So anytime that an object is in motion, it has kinetic energy. We have an equation to be able to calculate kinetic energy. So kinetic energy is 1/2 times the mass times the velocity squared. So the mass is in kilograms and the speed is in meters per second. And as you can see, because the velocity is squared, the faster the object is moving is more important. So the speed is actually a bigger factor in kinetic energy than the mass is. So let's go ahead and practice. So we have a 5-kilogram bowling ball rolling down the lane at a speed of 2 meters per second. So how much kinetic energy does the bowling ball have? So again, kinetic energy is 1/2 times the mass, which in this case is 5, sorry about the handwriting, times the velocity, which is 2, but now we need to square that. So 2 squared is 4. 4 times 5 is 10, and 10 times 20. So 4 times 5 is 20, and then 20 times 1/2 is 10. So the kinetic energy of this bowling ball is 10 joules. The second type of mechanical energy is potential, and this is stored energy. So this could be stored in macro objects, which would have to do within objects like motion or position, but this could also do with microscopic objects as well, because you can talk about the chemical potential energy, where there's energy stored in the chemical bonds in some of your substances. But in our macro objects, we have 2 types of potential energy. So we have elastic potential energy, and this depends on an object's shape. So if you think of a spring, when you extend the spring and then you release that spring, it wants to go back to its original position. The second type of potential energy is the gravitational potential energy, and this is the potential energy that depends on the mass and height. And there's another equation that we can use for the gravitational potential energy. So this is mass times the gravity times the height. And the gravity, because as long as we're on Earth, gravity is going to be a constant number. So you can round that up to 10, or you can actually leave it as 9.81 meters per second squared, because that's the acceleration of gravity here on Earth. So here is another practice problem. So we're going to take the same 5-kilogram bowling ball resting on a shelf that's anxiously waiting to get picked. The shelf is 1 meter tall, so how much potential energy does our bowling ball have? So the GPE is going to be the mass, which is 5, times gravity, which we're going to use the 9.81 because we want to be very specific. And then we're going to multiply that times the height, which is 1. So the object's potential energy, on my calculator, I get 49.05, but I'm just going to round that to 49 joules.